Welcome to Metrology lecture series. In the present video, we will discuss the maximum metal conditions and the least metal conditions. First, we will discuss the maximum metal conditions. Maximum metal condition is the upper limit of an external feature, that is the shaft. For example, a shaft is manufactured to its high limits will contain the maximum amount of metal. So, upper limit of the shaft is the maximum metal condition. Similarly, maximum metal condition is also the lower limit of an internal feature, that is the hole. For example, a component that has hole drilled in it to its lower limit of size will have the minimum amount of metal removed and remaining in its maximum metal condition. So, for the hole, lower limit is remove the minimum metal and it having the maximum metal. Therefore, maximum metal condition for hole is the lower limit. So, this condition, maximum metal condition, corresponded to either the upper limit of the shaft or the lower limit of the hole. So next we have to discuss the least metal condition. Least metal condition is the lower limit of external feature, that is shaft. For example, a shaft will contain minimum amount of material when manufactured to its lower limit. So, least metal condition for the shaft is the lower limit. Similarly, least metal condition is also the upper limit of an internal feature, that is the hole. For example, a hole will have the maximum amount of metal removed when a hole is drilled in it to its higher limit of size. So, for the hole, upper limit is remove the maximum metal and it having the least amount of metal. So, therefore, least metal condition for the hole is upper limit. So, least metal condition corresponded to either the lower limit of the shaft or the upper limit of the hole. So next we have to discuss about this maximum metal limit and the least metal limit for the shaft with one example. Let's consider a shaft having the dimensions of 40 plus or minus 0.05 mm. So here it is given the upper limit as well as the lower limit, that is the 0.05, and the basic size is the 40. Then maximum metal limit of the shaft will have the dimensions of 40.05 mm, because at this higher limit shaft will have the maximum possible amount of material. So maximum metal limit for the shaft is the upper limit of the shaft. So here upper limit of the shaft is 40 plus 0.05, that is 40.05 mm. Similarly, shaft will have the least possible amount of metal at a lower limit of 40 minus 0.05 mm, that is 39.95 mm. And this lower limit of the shaft is known as the minimum or least metal limit. So least metal limit for the shaft is the lower limit of the shaft. So here it is given the basic size is the 40 and lower limit is minus 0.05. So lower limit will become the 39.95. Similarly, we will be discuss the least metal limit and the maximum metal limit for the hole. So let's consider the hole having the dimensions of 45 plus or minus 0.05 mm. Hole will have the maximum possible amount of metal at a lower limit of 44.95 mm, and the lower limit of the hole is designed as the maximum metal limit. So for example, when a hole is drilled in a component, minimum amount of material is removed at the lower limit size of the hole. Then this lower limit of the hole is known as the maximum metal limit. Similarly, higher limit of the hole will be having the least metal limit. So here it is given so higher limit is the 45 plus 0.05. So at a higher limit of 45.05 mm of the hole will have the least possible amount of the metal. So least metal limit for the hole is the upper limit of the hole, and similarly maximum metal limit for the hole is the lower limit of the hole. Next we will discuss the allowance. Allowance is the intentional difference between the maximum material limits, that is the lower limit of the hole and upper limit of the shaft of the two mating parts. So allowance is the difference between the maximum material limits. We know that when the maximum material limit for the hole is the lower limit and maximum material limit for the shaft is the upper limit. So allowance is the differences between the lower limit of the hole minus upper limit of the shaft. So remember this formula. So allowance is the lower limit of the hole minus upper limit of the shaft. And allowance is the prescribed difference between the dimensions of the mating parts to obtain the desired type of the fit. If the allowance is positive, it is the clearance fit. If the allowance is the negative, it is indicated as the interference fit. So allowance may be positive or negative. If the allowance is the positive, mean it is the clearance fit, and if the allowance is the negative, mean it is the indicated as the interference fit. So thank you.